Welcome back, sustainable construction project managers and structural engineers. Today, we're diving into a brand new explainer all about optimizing compressed, stabilized earth blocks for your large-scale builds. If you're looking to push the boundaries of masonry, cut down your costs, and drastically lower your project's carbon footprint, well, you're in exactly the right place. We're going to look closely at some really fascinating research on biostabilization that is literally changing how we approach earth construction.
Okay, so our roadmap for today covers 5 key areas. We've got the baseline, the catalyst, the blueprint, the performance data, and finally, the bottom line. Let's get right to it.
Starting things off with Section 1, the baseline of modern earth blocks.
So, compressed stabilized earth blocks, or CSEBs, are a highly engineered building material. And right off the bat, notice that we are engineering soil here, never ever dirt. We're talking about a very specific, careful matrix of clay, silt, and sand. But here's the historical catch. The traditional method for stabilizing this soil relies heavily on cement and lime just to give the blocks their structural integrity. And as we all know, cement consumes a massive amount of energy to produce, which really drives up both the cost and the carbon footprint of your entire build.
All right, let's move right into Section 2. Meet TerraZyme biostabilization.
Enter TerraZyme. This stuff is a non-toxic liquid bio-enzyme formulated completely from vegetable extracts. But hey, don't let its organic nature fool you. TerraZyme only requires microdoses to act as a seriously powerful catalyst. When you introduce it to the mix, it modifies the subgrade soil to drastically decrease its swelling capacity and bring down its permeability. It effectively forces the soil particles closer together, which maximizes compaction and completely changes how the earth behaves under stress.
Now, you might be wondering, why does combining this enzyme with cement and lime actually work so well? Well, it's all about the micro-level engineering. The enzyme prompts soil bacteria to release hydrogen ions, and that creates localized pH gradients right there at the surface of the clay particles. The shift in pH actually breaks up the clay's lattice structure, which releases silica right into the system. And here's where the magic happens. When you have lime present, calcium ions are also released. That calcium and the newly freed silica interact powerfully to produce these incredibly dense cementitious products. The result? A much more durable, completely locked-in building block than you could literally ever achieve with just cement alone.
Which brings us to Section 3,
The blueprint, block manufacturing process.
Okay, so let's outline the exact step-by-step process of mixing TerraZyme with your soil on site. Step 1 is just your standard dry mix, combining your carefully graded soil, sand, and those reduced quantities of lime and cement. Now, Step 2 is the real game changer. You inject your microdose of the diluted organic TerraZyme stabilizer directly into your water source. In Step 3, you introduce that enzyme-rich water to the dry materials for a wet mix lasting just 2 to 3 minutes. That's it, just enough to ensure uniform distribution. Finally, in Step 4, you transfer the mix to your press, compact it, and eject the block. It is a remarkably seamless integration into standard CSEB production.
As you'll see on site, the immediate output yields these crisp, perfectly formed earth blocks ready to go. But, as any structural engineer knows, simply forming the blocks is really only half the battle for structural integrity. What happens next completely dictates the lifespan of your masonry.
To ensure maximum strength and long-term durability, you absolutely must strictly follow this 28-day curing rule. These enzyme-treated blocks have to be cured in the shade and kept constantly moist for a minimum of 28 days. No skipping this. This extended moist curing process is absolutely vital because it gives those micro-level cementitious reactions we talked about earlier, between the silica, the calcium from the lime, and the enzyme, the time and hydration they need to fully develop and lock that soil matrix together.
Moving right along to Section 4, the performance data, superior structural durability.
Now, these blocks aren't just theoretically stronger, they are rigorously stress-tested. Researchers actually use universal testing machines to crush these blocks under wet conditions. And for earth materials, that is literally the ultimate worst-case scenario. They test them like this specifically to ensure they can handle the really intense demands of large-scale masonry projects.
And guys, the results are just staggering. After 2 months of aging, blocks prepared with TerraZyme showed an astonishing 30 to 50% increase in wet compressive strength compared to control blocks made without the enzyme. I mean, think about that for a second. By simply adding a microdose of vegetable extract to your water, you're yielding up to 50% more structural capacity in your masonry. That is huge.
Furthermore, the data shows a continuous decrease in water absorption over time for the enzyme-treated blocks. This is a massive win for durability. It means that internal cementation process successfully blocked the poor interconnectivity within the block itself. Less water getting inside means less weathering, less expansion, and vastly superior long-term durability for your structures.
Finally, let's wrap things up with Section 5, the bottom line, the project manager's advantage.
When we compare the cost efficiency of enzymatic stabilization versus traditional methods directly, the advantages are pretty crystal clear. Traditional cement-only methods carry high material costs, massive embodied energy, and interestingly enough, their strength actually plateaus at around 6 months. Enzymatic stabilization, however, completely flips the script. It allows you to achieve comparable, or as we just saw, superior strength while drastically cutting down the volume of expensive cement you actually need. Plus, because of the ongoing interaction between the enzyme, the soil, and the lime, these blocks experience continuous long-term strength gain well beyond the 2-year mark. It's just a highly sustainable, highly efficient alternative.
I think this quote from the research brilliantly summarizes the ultimate value proposition here. By slashing that cement reliance with just small quantities of TerraZyme, you aren't just saving significant money on materials, you're actively reducing the embodied energy of your building units. This massively enhances the green rating of your entire construction project, making it so much easier to hit those strict sustainability targets and secure green building certifications.
So with the structural and environmental blueprint fully laid out, the real question is left to you. We've seen how microdosing bioenzymes can increase strength by up to 50% while slashing costs and carbon. So how will you integrate this high-performance, cost-efficient biostabilization into your next large-scale masonry build? Think about your upcoming projects and imagine the impact this could have. Thanks for joining me on this explainer, and we'll catch you on the next one.